My name is AslamParker. I'm from Chief Directorate National Geospatial Information. Just for those of you that don't know, we were called Service and Mapping before. And before that, I'll probably be in South African Spatial Data Infrastructure. And so that was an important additional mandate that we have incorporated. And therefore, we necessitated the name change from Service and Mapping to National Geospatial Information. The legislation that gives us our funding or votes from Parliament is basically the Land Survey Act. We have significant input to the Geographical Names Council, and we also are the Secretariat for the South African, the SDI, and we also then bound by the Spatial Data Infrastructure Act. We have to, besides being a major custodian and collector of information, we provide the Secretariat to that committee as well. There are many duties that are outlined in the legislation, but I just thought I'd highlight one or two of them. And you can notice I highlighted the aerial imagery. We have to acquire, according to the Act, we have to acquire aerial imagery as may be required. We have a forum called the committee. The annual forum, I'm just getting a blank here. NEMAC, yes, of course. We have the annual NEMAC meeting that happens once a year where we solicit needs from users. We have to establish a national control survey system in South Africa. We compile maps, and you are all aware of the maps which we make. And importantly, the last one I want to very briefly touch on is we have to take charge and preserve our records as well. So other than many other collectors of aerial imagery and information, we have a legal obligation to preserve it. And that is a very important function that has to be ignored sometimes. So these are our key, at a very high level, our key products and services. Aerial photography that you are aware of, geodetic and control survey services, maps and geospatial information, the SDI, and professional advisory services. The first area that I feel you need to be aware of in terms of Earth observation holdings is the National Control Survey Network. I think many years ago what we did have was the hundreds of trig beacons, thousands of trig beacons and node points for horizontal and vertical control benchmarks in the country. We maintain and sustain those as well. And obviously as GNSS technology has evolved to enable accurate positioning, we've established a network of continuously operating reference GPS base stations. We've operationalized this in about year 2000, 1999 onwards. And might not be the latest one, but this is more or less what the network looks like. And at each of these points we have a permanently operating GPS reference station in the rural areas, the spacing is about 200 to 300 kilometers, and you see in the very built-up areas we have these dense clusters of stations providing positioning at the sub-centimeter all the way to decimeter level, depending on the accuracy requirement. So this is one service that we provide. Just a fancy sketch here showing the whole principle of carrier phase precise positioning, and you can see the reference station collects data all the time from satellites, which gets combined with user data to provide very precise positioning. These are our services in terms of real-time services. We have single base RTK. RTK is a technique for very precise positioning at the centimeter level. So you could be anywhere in the country, and if you connect up to one of our TriGnet stations with appropriate GPS receiver, GNSS receiver, you can position yourself to within sub 5 centimeters anywhere in the country, really. And we have a network RTK solution in those dense cluster areas that I've shown in Cape Town, Gauteng, and KZN. This makes it possible for very rapid and very precise positioning in those areas as well. For the people who do not need the real-time navigation and real-time services, we have the standard Rhinex products, and here's the FTP site for all of that data. This is used extensively by scientists and surveyors, and we have daily products and hourly products. This presentation will be available, Terry can make it available as well, so if anybody is not able to make notes, we can get the presentation later. Yeah, the other applications of TrigNet is, for example, there's been demonstrated the use of TrigNet to look at plate motion within South Africa, because we have, for the first time, we have permanent GPS stations. We can look at time series and we can look at the motion of stations relative to each other. This is still a bit of an unknown thing, and as we evolve this time series, as we have more and more data, we will better understand how South Africa is moving within each other. I think about 15 years ago, we thought South Africa was a stable plate, and then later, we said, nah, maybe the Nubia is sitting somewhere near the top, and now there's even talk that within South Africa there's another small plate at Durban, and my colleague Richard Wanacott, who perhaps, if you want to talk to him later, you can do that. But the GPS, the permanent reference stations, is providing an invaluable tool for this kind of analysis of plate motions within South Africa. Here we also look at TrigNet has been demonstrated to very effective for ionospheric mapping and variation of the total electronic content over South Africa. And here's very interestingly, you can see a diurnal cycle and a seasonal cycle of what the, there's a very clever mapping of that, of what the tech content is doing over South Africa, both over time of day and over the various seasons. You can expect in June and July you'll have minimal ionospheric activity, and as the summer season goes along, you'll see different activity. And then also as we go to the solar max, we know that this will also have an effect on GNSS, and we're busy looking at that as well. So that just touches on some of the scientific applications of TrigNet, and we encourage everybody to participate in further, to use the data. It's freely available. We've got a time series basically coming from 2000 on some stations, and obviously on the newer stations as and when they were established. So we have data spanning back. The oldest one is in the late 1990s. Another last example is the comparison of radio sound estimates with GPS-derived precipitable water vapor estimates. Those big balloons that the weather people release? They don't do that anymore, thanks to the successful use of GPS to derive this information. And this is now successfully implemented in South Africa, and you can see the huge correlation with GPS derived PWD data and radio sound data. And this is now a globally implemented techniques. The next area of Earth observation data that I want to talk about is, as I mentioned earlier on, we have a mandate to acquire aerial photography, and that's changed now, aerial photography and imagery and other remotely sensed imagery. Now, again, in terms of legislation, it says we need to do this, and we need to also then clarify what is the role of an agency like NGI compared to like SANSA. And there is maybe there is a dividing line, and we need to just kind of settle on what is a dividing line and move on. But No, it's a question that we've asked ourselves even at previous meetings, Terry. Remember, what is the role of aerial imagery, and where does it stop, and what is the role of that? What is that mandate meant to be? And I think it's an historic one, which perhaps didn't preempt what is coming up now. And you can see we have digitally scanned unrectified imagery. In fact, we've got thousands of jobs dating back to 1928. The value of this archive is really unappreciated. And I think even within ourselves, we don't appreciate. I was slapped with an audit finding 2 weeks ago and said, you're not doing enough to preserve these records. There is no other record in South Africa that dates back and that is preserved and maybe it's not preserved as well as it should be, but there's no organization that houses information like you are doing, and you've got to do much more to preserve that record. So not only must do we have to physically preserve the film, we must make sure that we have backups in terms of like the data still retained. So we are frantically getting into that exercise of trying to backscan at very high resolution all the old stuff, and as I said, rather late than never, and obviously also rectified imagery as well. And you can see the evolution of our imagery over time. the emulsion in 1928 was very protein-based, and it's very not very stable. In the 1960s, probably marked the start of very stable emulsion. So our real concern is pre-1960. Yeah, here's just a bit of a demonstration of the District 6 famous area. That was before. Now, with land restitution, where most people for land restitution, for example, didn't own the land, historical imagery is the only evidence, physical evidence that you can have to justify the land claim. So the value of this, even just for land restitution, is huge. We've had cases in the 1940s and 50s, people were displaced. The only evidence that you can have, because the landscape has changed entirely, is aerial imagery records, and what we also have is historical map records. We have annotated maps in the 1930s and 40s, and we show here as Hatsi and things like that. So this has successfully been used in court cases many times, and so we've successfully validated land claims like this. So the value of this is huge, and this is just to show the destruction of District 6. Sorry, my animation went out there, but I think this is a slide that talks about the contention with satellite sensors, and you can see around at the 1 meter level the aerial cameras and the satellite sensors, they overlap, and this is this is where there is an overlap, and this is unavoidable. This is not something that we must try to hide around. I mean, recently Digital Globe has now launched their new product. It's called Digital Globe Online. They provide a service where ArcGIS, for example, you subscribe to the service, they will provide you the latest imagery in South Africa. So they see that imagery, before you couldn't access satellite imagery as easily. Now they're providing a global service on the cloud, and you can use ArcGIS, hook into this global imagery service, and you can go and compile off the imagery. You can't download the imagery, but at least it's a... So satellite, people like Digital Globe is seeing this big potential in this. And this is testing what is the future for aerial imagery programmatic acquisition. So it's something that we have to question and saying, where is industry going? Where are the trends going? So what we're seeing now is companies like Digital Globe saying, we'll host the imagery for you. You don't have to even buy it from us. You don't have to download it. It'll just be served as a backdrop. So this is an interesting trend that we have to analyze as a national mapping agency who's acquiring imagery on a programmatic fashion. And so if these things are becoming that accessible, what is our role? So we have to continue to reevaluate that. The space that is sub 10 centimeters, I don't think for the foreseeable future, but things can change very quickly. That's still dominated by aerial sensors and of various types. But you can see, so before the satellite sensors played a very distinct role, but now there's this big overlap, and we're going to strategize around that.